This is section 4.8, graphs and derivatives of implicit relations. This is the second day we're working on this. So it's just kind of a recap and diving in just a little bit deeper, but not a lot to it. So stay with me. We want to be sure that we are able to find the derivative of y with respect to x, and even towards the end, maybe the derivative of y or x with respect to t when we're given an implicit relation. Starting with some random true-false problems here. We have the slope of the tangent line to the differentiable function f at the point 2, f at 2 is f at 2 plus delta x minus f at 2 all over delta x. Try to decide if that's true or false. I'm not going to give you the answer since we're doing them in class. F is increasing, then f prime is greater than 0. And then the third one, if f prime of x equals 0, then f must have a maximum or a minimum at x. Okay, here's our first problem. Y equals sine of xy. We're supposed to find dy dx, which we're used to doing, and then we're going to make a change and find dx dy. Well, let's start with what we're used to. First thing we should notice is right here, these are multiplied. Okay, they're an inner function. Sine's your outer. Okay, so we're going to have to do the chain rule, and when we do the chain rule, this right here has got to be done with the product rule since they're multiplied. So, finding dy dx, take the derivative of y, and we get dy dx equals, derivative of sine is cosine, and remember when you do the chain rule, everything inside stays the same. You're taking the derivative of the outside function first, inside stays the same. But then, by the chain rule, we got to do our product rule here. So it's my first times my derivative of the second plus the second times the derivative of the first. But we're doing this with respect to x, so I do not need my dx. Dx is going to go to 1. Okay, distribute through, and I have dy dx equals cosine. When I multiply cosine xy times x dy dx, that's x cosine xy dy dx. Then I distribute it over to the y, so that's plus y cosine xy. Okay, now y'all pause with me because I'm going to make my pen a little bit thinner because it's driving me crazy. Okay. So all my dy dx terms have got to be on the left. Things without dy dx have got to be on the right. So I get dy dx minus x cosine of xy dy dx equals y cosine y. Or excuse me, cosine xy. dy dx is in common over here on the left-hand side. If I see that, that's in both terms. So I factor my dy dx out. And that leaves me with 1 minus x cosine of xy. It is really easy to forget that 1 at the beginning, so make sure that that is in there. When you take something out completely, it doesn't leave it with nothing. It leaves it with a 1. So that you can distribute back through and get the same answer that you started with. From there, I need to divide both sides by this right here, the 1 minus x cosine xy, and when I do that, I am left with dy dx equals y cosine of xy divided by 1 minus x cosine of xy. And there you go. Easy enough. Y'all have been doing that. Shouldn't be a problem. Let me make a little line right down and through here. Give myself a little room so that I can do the dx dy. This tells me when I trade this, I wanted to just do this and kind of give you a taste of it. I'm taking the derivative of x with respect to y now. Okay? So, as I go through this, when I take the derivative of y on the left-hand side, well, that just leaves me dy over dy, which is 1. I no longer have to put the dy dx because I wasn't taking it with respect to x anymore. I'm taking it with respect to y. So now my left-hand side is 1 equals, still on the right-hand side, outside function is a sine, so the derivative of that is cosine xy. Again, chain rule, got to take the derivative of the inside, so that's going to be the first times the derivative of the second, but this time the derivative of y is just 1. So I've just got my x there, plus the second, that's going to be a y, times the derivative of the first. Well, now my derivative of x with respect to y from this right here is going to give me dx dy. Distributing through, and I have 1 equals cosine of x, y. Oh, excuse me, forgot to put the x in the front of it. Let me put that back in here really quickly. Oops. Okay. Now, gotta make my pen thin again. There we go. Every time that I pick up the eraser, it makes things... Okay, we're close. 1 minus x, it makes things get big again. 1 minus x cosine of xy plus y cosine please forgive me because my pen is a little off. I'm just going to rewrite this very fast. Okay. Okay. 1 equals x cosine xy plus y cosine xy dy dx dx dy. And we'll eventually get there on this problem. What should have been a very simple problem is now a little bit frustrating because of all this stuff. So sorry. First two terms, my 1 and my x cosine xy, do not have dx dy's with them, so put them on the same side. 1 minus x cosine of xy equals now y cosine xy dy dx, dx dy. To get the dx dy by itself, I need to divide both sides by the y cosine xy. So at this point, I can write my final answer. Dx dy equals 1 minus x cosine of xy divided by y cosine of xy. All right, there you go. There's your solutions. Not a problem. Let's move on. Okay, now here's our little bit of a challenge problem. We want to find the second derivative of this implicit relation. Again, first two terms are multiplied. We are doing this in terms of dy dx, not dx dy, so I won't get my tongue tangled anymore. Out of habit, I always say that other, but here we go. Let's take our derivative right here. So, first times the derivative of the second, that is going to be 2y dy dx. First times the derivative of the second plus the second times the derivative of the first, so times the 2x right there. Simple enough. Minus, derivative of 2x is just 2, equals, derivative of 3 is 0. Y'all don't forget to take the derivatives constants and make them 0. Okay, we're trying to get our dy dx by itself. This term right here is the only one with dy dx in it, so it's going to stay on the left-hand side. Everything else is going to move to the right. So I have x squared, or let's do 2x squared y dy dx equals, moving the 2 over, minus the 2xy squared. Okay, so that means this term is going right here, and this term right here is coming down right here. Okay. Hopefully we're good on that. Divide both sides by 2x squared y, and I have dy dx equals 2 minus 2xy squared divided by 2x squared y. There is a 2 in common there that I can factor out, so that'll be 2 parentheses 1 minus xy squared divided by 2x squared y, and cancel my 2's, and so my final dy dx is 1 minus xy squared all over x squared y. But if you notice, what I asked you to find was to find the second derivative. Okay, that means I now have to take the derivative of that, just like we've done on all of our other things. If you have once you find the first derivative, you're able to take the second derivative. That gives you acceleration if you're looking at motion problems. So let's take our second derivative. That's going to give me, and this is the way your notation reads, okay, on the top, the 2 goes with the d, because you're taking the second derivative of y with respect to x, and it's the second time you're doing it with respect to x, so it's the 2 right there, okay? So equals, now when I look back at what I had, I've got to do a quotient rule on this one. This one's a little bit tricky, so y'all stay with me. I've got my bottom, x squared y, times the derivative of the top. Well, the derivative of 1 is 0, so that's gone, okay? Then I have a minus sign, so this is going to be a negative, and then I've got to do the product rule, okay? So I've got first times the derivative of the second, which is going to be a 2y dy dx, plus the second. Let me put another little parentheses in here. First times the derivative of the second, plus the second, which is a y squared, times the derivative of the first, which is a 1. Okay, all over the bottom. Oh, time out. I have bottom times the derivative of the top. And we're over the bottom squared here, but don't forget, what I've got to do is to, that's only the bottom times the derivative of the top, okay? Minus, I had to put it over the denominator there. I don't want to throw you with that, but I'm running out of room. Minus the top, which is 1 minus xy squared, times the derivative of the bottom, which again is going to be a chain rule first, times the derivative of the second, plus the second, times the derivative of the first. Okay? And again, the deal is that it's just a little bit long for me to get in there, so I had to put each of them over that denominator square. So bottom times the derivative of the top, minus the top times the derivative of the bottom, all over the bottom square. So that's going to equal, I'm going to stretch out a little bit here and see if I can get some more room so I can get it on one line for y'all. All right, when I start to work these problems, and I'll try to simplify as I go, but wherever I had dy dx, my dy dx has to go in there. So this is going to give me x squared y times negative 2xy that is multiplied times dy dx, which is 1 minus x squared y, xy squared, excuse me, all over x squared y. Plus y squared. Okay, so that's my new bottom times the derivative of the top, right there. Minus distributes through and makes this a minus, so let's change that to a minus y squared right there, so that I don't lose that. And then minus my top, 1 minus xy squared times the derivative of the bottom, which is going to be x squared times 1 minus xy squared all over x squared y plus 2xy. Ooh, running out of room there. Plus a 2xy. Let's see if I can write it going up so y'all can see a little better. All over x squared y squared. Okay, so we're a little bit better there. Okay, distributing through. This is going to be x squared y times my x and my y will cancel with one of the x's and y's down there, so I'll have a negative 2 times 1 minus xy squared all over x, because the x and the y canceled with that other, plus, or minus, excuse me, y squared, minus, parentheses, 1 minus xy squared, times, my x squared is going to cancel and leave me with 1 minus xy squared all over y, plus 2xy. And we finally got it all to fit in there. All over x squared y, the whole thing squared. All right, and then from there you could continue to distribute through, and I need to close that, put a parentheses in right there, and could continue to distribute through and simplify things, but I think at that point I'm running out of room and I'm going to leave it with you because this is getting long. All right, thank you. Moving on. Normal line, don't forget that normal lines are ones that are perpendicular to the tangent line. Okay. So your normal line to this ellipse, you've got to take your derivative. Derivative of this right here is going to be, if you think about this, you can rewrite this. I don't know if this will help y'all or not. If you think about it as 1 over 32 x squared plus 1 over 8 y squared equals 1. And so when you start to take your derivative of this, then with respect to x, we're doing dy dx here because we want to find the slope of the tangent line first. Then this becomes 1/16 x, because when the 2 comes down, it cancels with the 32, plus 1/4 y dy dx equals 0. Subtract the x over, since it does not have a dy dx attached to it, so you've got 1/4 y dy dx equals negative 1/16 x. Multiply both sides by 4, you can do that, and divide by y, and dy dx is going to be a negative x over 4y. Multiplied by 4, made my 1/16 reduced to 1/4, divide by the y, put the y in the denominator on both sides. Okay, so now then, dy dx is my slope. That's the slope of my tangent line. Okay, so what I want to do is plug in my 4 and my 2. And reduce that. Negative 4 over 8 is a negative 1/2. That's the slope of my tangent line. Okay? Slope of the tangent line at the point 4, 2 is negative 1/2. Well, then that means that the slope of my normal line is going to be the negative reciprocal of that. So the slope of the normal line is going to be a positive 2. Come back in now. Let's move over here so we've got some room. And y is going to equal my slope of 2 times x minus 4 plus 2. And this is your normal line. Easy enough. This one's a little bit different. It says, given that dx dt equals 3, find dy dt when x equals 4. Okay. So very quickly taking my derivative, dy dx equals 1/2 x to the negative 1/2. Oh, no. No, 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 no. Dx dt. We're doing these in terms of t. Dy dt equals 1/2 x to the negative 1/2 dx dt. Switching pinlets again. Okay. So, it says to find dy dt when I have 1/2 and my x value, it says, is 4 to the negative 1/2. And my dx dt, it says, is 3. So that's going to be a 1/2. And then a square root, or a negative square root like that, so I'm going to move that to a 1/2 times by 3. And that is 3/4. And so that's pretty easy. It's not a big deal when you change it to t. It's just you have to put it on both values, y and the x. Okay. Given dy dt is 2, find dx dt when x is 25. Well, you're looking at the same formula, which I should bring down here so I can see. Dy dt equals 1/2 x to the negative 1/2 dx dt. Okay. And so we're going to plug in the numbers that they give us on this one. Dy dt is 2 equals 1/2 times x is 25 to the negative 1/2 dx dt. Multiply both sides by 2, and I've got 4 equals 25 to the 1/5 is going to be a 1, or 25 to the negative 1/2 is going to end up being a 1/5 dx dt. Multiply both sides by 5, and so dx dt equals 20. So, easy stuff, not too bad. We're in good shape. And this is a pretty tough problem that, if it's okay with you, we're going to wait and do together in class. Make sure that we understand it. May end up doing it even tomorrow when we're doing related rates. So, there is your lesson for today, and hope y'all have a good evening. Bye-bye.